Alright, so the power supply that I'm using today is this solid gear supply. I don't really know who that is. I got this at the Micro Center store. It was on sale, so it was $20. It's a 500 watt supply. And the only, I've mentioned before, the only thing I'm interested in is this number here, the amount of current that the supply gives you at 12 volts. So this one claims 26 amps, which is more than sufficient for powering a single heat bed and 5 stepper motors. So let's see what we've got in here. So the dedicated 12 volt supplies that are used for mostly, I think they're made for LED lighting, are getting real popular, and those are nice if you've got one. But it's hard to beat, I think, these ATX supplies for cost versus performance. This one has a 120 millimeter fan. Hopefully it's going to be kind of quiet. And this bunch of cables here is really all I wanted to talk about today. Now this one actually has sleeving on the main connector, which is nice, so I'm going to try to save that. But I'm otherwise going to remove all of this because I don't like to have a whole gob of wires bunched up behind the printer. And I'm just going to turn the printer around here for a second so that you can maybe visualize the power supply is going to be in this back left corner as usual, and I want the line cord to come off the back towards the wall, so that leaves all of these pointing towards the front. And the only thing we really need is 12 volts up to our ramps board. I've got a new ramps board here. So of all of these wires, see what we've got here. And this connector's got 12 volts in ground, all ready to go. Like I said, this large one is got most everything else. And I'm going to save, I always like to save at least one of these wires that terminates in a standard Molex 4-pin connector, because then you've always got 12 and 5 volts if you need it to power a fan or some lights or something else. So our strategy is to keep these two and get rid of everything else. But before we start, because we're getting ready to seriously void the warranty on this supply, it's a really good idea to go ahead and power it up and test it to make sure that you don't have a unit that's DOA. So I'm going to plug this in. Alright, now it's plugged in, but in order to get it to power up, we'll need to short the power supply on connection that is provided on this connector. And we don't want to start modifying it yet, so to do that I'm just going to use a short piece of wire. Alright, so here is a little short piece of wire that I've just cut, trimmed, and on this main power connector there's a single wire that's green, and onto either side of it on the same row is a black wire, and by shorting that green wire to the black wire, either one, then that's going to enable the power supply to turn on when we turn on this switch in the back. So our fan starts to spin, power supply's on, but there's no load on anything, so that's not quite finished. So to test whether it can actually power our printer, this is the heat bed that I'm using, and I've already wired it up. I've got these two wires, a thermistor, and it's taped down to the back, and then the wires are back here. Now, and just as a side note here, you can see I've used this, I use this PET sleeving, and I love this stuff for protecting wires. You know, it turns 4 wires into one nice smooth package that can glide a lot better, does not get caught on things. But anyway, what I'm going to do is I'm going to connect the 2 leads for the heat bed. We've got the power supplies turned back off again now. So with my 2 heat bed leads, I'm going to connect here to 12 volts and ground. And our goal here is just to see that our power supply works before we start cutting into things, because they will not take the power supply back if it's not working after that. So I'm just going to turn it back on, and you can see here the little LEDs come on the heat bed, and it is getting nice and warm. Power supply is not making any funny sounds, so I would declare that this supply is ready for use. I'll turn it back off. Just like that. And we'll pull this wire back out. And very important, disconnect your AC mains from the supply. We do not under any circumstances want to do any of this with that connected. So and in fact a good idea after you've done what I just did here would be to go away and let this guy sit for a little while. And the reason is inside here there are among other things capacitors that are used to run the power supply regulators, and they could have hundreds of volts on them at this point. So if you let it sit for a few minutes, all of that charge is going to go away, and that is a good idea just to be safe. Okay, so now we've let that sit for a little while, and we're ready to get on with the whole point of this video. So again, these are the wires that I want to power my ramps board. And I'm just going to start by cutting off that connector that the power supply came with. And there is a little zip tie on here. I don't want that. And the wire here is about 1 foot long. Before I do anything else, I'm going to put some more of that sleeving over it. So this is a smaller, this is a I think 4mm PET sleeving. So it's kind of on the small side, but it'll work great for 4 wires or so. And I'm just going to cut a little bit of that off. Okay. And if the ends get too frayed, get scissors and just trim them off. We don't need lots of loose ends. And then get our 4 power supply leads that we're using. So again, besides just trying to make it look nice, this really serves a purpose, and that purpose is to prevent as much opportunity as we can of wires getting caught on moving parts of the printer or anything else on your desk, and getting things that get yanked off, and then our printer doesn't work and we are sad. So now that I've got that on, I'm going to go ahead and trim these leads, or trim the insulation back. ramps board. Comes with these two connectors. And what we will need is a small flat blade screwdriver. Alright, so here's that. And actually before we put those on, because they're kind of bulky, I'm gonna get this small piece of heat shrink tubing. This is, what is this, a 1/2 inch wide? Must be 10 millimeters because it says Theta 1010. Anyway, some heat shrink tubing of the size of your finger. And I'm going to cut off about, is that an inch? Put that over all four. Try not to make a real mess of this. All the way down to the other end. Another piece, about the same length. Should have done that before I trimmed these, because now you can see they're all frayed. And then this one is going to go over this end of the braided PET there, so that it's going to be nice and protected. And then get the heat gun. Alright, so yeah, here's my heat gun. And you could also use a lighter, I suppose, maybe even a hair dryer if you have one that's hot enough. And make sure that the heat shrink is covering the end nicely, and just shrink that down. And then same thing on the other side. Depending on if that heat shrink, is just the right size, or if it's maybe a little bit too big, you can put a zip tie around that too now, just to really hold it on there. So now that's real nice. So get those cleaned up. Now on the power into ramps, you can see here where it says plus, minus, so this is plugged in like such, like that on either side. The plus is on the left, so the yellow wires want to be to our left, so I'm going to put one in. Okay, now look real closely. Look real closely after you're done and check and make sure there aren't little pieces of the strand from the wire poking out to the sides. If there are, then just take this off and just start over. And if it's getting, if they're getting really messed up, then trim them back. But make sure when you're done that that's nice and clean. There's nothing sticking out. If these two short together, then it's bad news. And if they aren't well connected into here, then there can be some resistance in the connector between the wires and the connector itself, which will lead to the connector getting extremely hot and melting. So this is important. Now I'm just going to do the other one same way. So those are ready to connect. Now, there's the matter of all the rest of these wires. Now you could leave all of this in place if you wanted, but I don't like having all of this extra wire. I do, however, like to keep one of these 4-pin standard Molex terminated cables because you can connect fans and things like that to it, so I'm going to keep that. But this one, for instance, I don't want, so I'm cutting it off. And this big guy, oh wait, same with this one. These connectors are impossible to use anyway, so we're not losing anything. And then this big guy, we need to pay attention to. Like I said, I'm going to save this cable sleeving because I can reuse that. But to start, I'm cutting all the end of this off. And then it looks like we'll need a way to get into here. So Phillips. There we go. Now, see that? Yeah, here we go. So here's another zip tie I need to get rid of. That's going to let us get this sleeving off of here. There we go. Now, keep your wires that we want to keep here. Keep them to the side. All of this junk. We don't need all of this. Well, we don't need most of it. But the exception is, I'm going to pull these back through the inside here. Okay. Can you see all right? Now remember, we had to short our green wire to ground to get the power supply to turn on when we throw the switch. So get that green wire and any black wire that you can find. And trim off a little bit of the insulation. And you need to connect these two together, and you can do that any way you want. You can twist them, you can solder them. What I like to do is use one of these little crimp style ferrules. See that little guy? And I also will need another little piece of heat shrink to cover that. You could also just use like vinyl tubing or anything that you've got that's electrically insulated. Slip that over one of the two, and slip a little crimp connector. You can also use a so at the hardware store you can find something just called a butt connector, which is like this little crimp connector except it already has insulation around it. But I happen to have a lot of these, so I'll take each of these wires and I'll put a little hook on the end and then hook those two hooks together. And then slide that. There we go. Make sure it's kind of secure. Again, there won't be any power in this wire, so we just need to make sure they're connected there and protected. So I'll hit that with the heat gun. Okay, now depending on your supply, but more than likely yours will be like this one. There's two other wires, one or two other wires that you have to do something, you have to deal with. And the reason is because if you look at your original connector that we cut off, you see here towards this end, there's two pins on this side that have two wires going into them. And what these are is, the purpose of that is so that the power supply can sense what the voltage is down at the motherboard of the PC, so that it's not regulating the voltage to here, it's regulating it down to the PC. And why do we care? Because we aren't using 3 volts or this ground connection, but the reason you care is that if that sense lead gets dropped, in other words it gets cut like this, then the supply might not turn on at all. And in fact it probably won't. So we need to also provide these connections. So find those leads. Now on this one, it's probably impossible to see on the camera, but the 3 volt sense is kind of like a slightly different color of orange, so you can still pick it out. It's this one here. So we need to take that and one of the orange leads for the 3 volts, and we're going to short them together just like I did with the power supply on. The other one is the brown wire, and he needs to be connected to a black wire. Okay, so just repeat whatever you did to connect the green wire to ground, repeat that with these two pairs. Now, before we put the case back on, we have to do something with all these loose wires. And you don't want to just leave them dangling about. Because they will, if they can find a way to short something, they will. So what I'm going to do is separate, like here's all the orange wires. And we've trimmed them, they're flush, there's no wires sticking out, but that's still not safe. So I'm going to get a little more heat shrink tubing, and I'm just going to shrink over the ends of these, and then I'm going to do the same thing with the group of red wires, the group of yellow wires, and so on. And the heat shrink tubing that I'm going to use for that purpose, it's a little bit bigger, but also this kind has a adhesive on the inside lining, so that when it heats it melts like glue. If you don't have that kind, then another thing you can do is use a hot glue gun to kind of glue those together, and then put a piece of heat shrink down over them, and it'll help it ensure that it can't vibrate and the heat shrink comes off. And then finally, they were kind enough to include some zip ties with this power supply. That's nice of them. So I'm going to use those just to tie this whole bundle of loose wires up together. And then double check again and make sure there is not a single loose wire here that could short anything. Really take your time and check it over. And then when you're happy, you can put this back together. Anyway, so there we go. Now you can see how much cleaner this is. Just two little bundles of wire coming out of there. And when we assemble this with the printer, we're also you want to make sure that you find somewhere to secure this so that any pulling here won't pull against the connections in the power supply.